All right, so today we are going to talk about how to solve quadratic equations. Our essential question is, how do you determine what method to use when solving quadratic equations? So what that implies is that there are different methods, and we're going to talk about the different methods today and on Wednesday because we can't do them all in one day. So we're going to talk about the different methods to solving a quadratic. So go ahead and set your notes up. Okay. So here now are the different ways to solve. Let me go through them real quick before you start writing, and then I'll give you some time to write. Okay? All right. So the first method is graphing. So you talked about graphing in your last set of notes. And when you're graphing, all you need to do is find the x-intercept, and then that's going to be your solution. So wherever the graph crosses or touches the x-axis, that's going to be how you find the solution to your quadratic. So you should have seen that in your last set of notes, but let's say I have I'm over here trying to write on this screen over here and losing my mind. Okay. So if this is your coordinate plane, and then this is your quadratic, not that, because that's not a quadratic, and this is your quadratic, then wherever it touches the x-axis, that's going to be your solution. And in this case, there are two. And we'll get into that in a little bit, but graphing is one method. The next method is using square roots. So write the equation in the form of u squared equals d, where u is an algebraic expression solved by taking the square root of each side or by completing the square. That's kind of a lengthy process. Well, it's not lengthy. It has a lot of steps in order to learn. So we're going to talk about that next class period. Factoring is to write the polynomial equation and then use zero product property to solve. We're going to talk about that today. And then, of course, quadratic formula, which we will also talk about today on those problems that you cannot factor. So go ahead and take some time to write this down, and then we will get into our examples. Okay, let's keep it moving. All right, so our first example says solve by factoring. So we have x squared plus 7x plus 10. So the first thing we're going to do is actually factor. So the same thing that we did in the warm-up. So let's review the factoring again. So we're going to have a is equal to 1. B is equal to 7, and C is equal to 10, right? Okay, so I want to know what is going to multiply to give me 10 and add to give me 7. So what multiplies to give me 10 and add to give me 7? I'm going to start with 1 and 10. Does that give me 7? No. 2 and 5. Does that give me 7? Yes. So my two numbers are 2 and 5. So when I factor, I'm going to have x plus 2 times x plus 5. And this now is equal to 0. And there's one thing that I should have noted at the very beginning that I didn't, is that when you are solving by factoring, your equation must equal 0. Okay? If it doesn't equal 0, then you have to make it equal to 0 before you can factor. Okay? I should have said that in the beginning. Totally slipped my mind. Okay? So now we're at this point here where x plus 2 times x plus 5 is equal to 0, right? Okay, so now let's put a little side note over here to the right. And our side note is going to be something called the zero product property. And so if you're taking Cornell notes, this is something that would be on your left margin so that you can know what it is, okay? So the zero product property says that if A times B is equal to 0, then A has to equal 0 or B has to equal 0. What does that mean? That means that if I have two numbers, and if I multiply those two numbers together and the answer is 0, one of those numbers has to be 0, right? Because the only way I can get a product of 0 is if one of the numbers is 0. Right? So I have two numbers and I'm multiplying them together and the answer is 0, one of those numbers has to be 0. Okay? So I'm going to use that concept when I look at the factoring. So essentially, I lost my mouse again. Here it is. This x plus 2, this would be my A. And then the x plus 5, that would be my B. Because when things are in parentheses, they count as one object, right? So A has to be equal to 0 or B has to be equal to 0. Make sense? Do we understand where I'm getting that from? So from there, I can write two equations. My first equation is going to say x plus 2 is equal to 0 because that's A, or x plus 5 is equal to 0. So do we understand how I got those two equations? So now that I have them, I'm going to solve them. So if x plus 2 is equal to 0, I subtract 2 from both sides. So x would be negative 2. And if x plus 5 is 0, I'm going to subtract 5 from both sides. So x is negative 5, right? So my two solutions are x equals negative 2 and x equals negative 5. I'm going to erase that negative 5 because it looks bad. I'm going to rewrite it so it looks better than it does. So that's a negative 5, right? Okay. So now, this is a quadratic equation, right? A quadratic equation means that it's going to have x squared, right? So that squared is going to tell us that we can have at most two solutions. So is it okay for us to have two answers? Absolutely. If I were to draw this same problem, so that's my coordinate plane. Here's my graph. Not that, let me switch it over. It would probably look something like this. Or it could be upside down. Well, no, it's not upside down. It would definitely be right side up. It would look something like this. And then right here, that would be the point negative 2, 0, right? Because x equals negative 2. And then over here, oh, y'all, this is wrong. Let me start over. I messed up. I thought the answer was 5. Let's try that again. Okay, so then my equation would look like this. My graph would look something like this, right? Okay, and then this point would be negative 2, 0. And this point would be negative 5, 0. And those would be my solutions. Okay. Questions? Here's the next problem. X squared plus 11x plus 19 equals negative 5. X squared plus 11x plus 19 equals negative 5. So remember, I said in the last problem, the first thing you need to do is you need your equation to be equal to 0. So let's do that. To make it equal to 0, we're going to add 5 on both sides. So now we have x squared plus 11x plus 24 is equal to 0. All right? So now we know a is equal to 1, b is equal to 11, and c is equal to 24. Does everyone follow me here? Okay, so I'm going to stop, and I'm going to give you a couple minutes because I want you to try to work it out on your own. So take a moment now to try to work this out on your own before we look at it together. Okay, so what do I have to do? I have to figure out what times what is going to multiply to give me 24 and add to give me 11. All right. So 1 and 24, nope. 2 and 12, no. 3 and 8, oh, 8 plus 3 is 11, perfect. So that means I'm going to have 3 and 8. So when I factor, I'm going to have x plus 3 times x plus 8, and that's going to be equal to 0. And then in order to solve, I'm going to do the zero product property. So that means that x plus 3 is equal to 0, or x plus 8 is equal to 0. So x would be equal to negative 3, or x would be equal to negative 8. Questions? All right, next one for factoring. So we have negative 4x squared minus 8x minus 3 is equal to negative 3 minus 5x. So of course, the first thing that we need to do is we need to make it equal to 0. So I'm going to add 3 on both sides. So I have negative 4x squared minus 8x, negative 3 plus 3 is 0, is equal to negative 5x squared. Okay. Then I'm going to add 5x squared on both sides. And now I have x squared minus 8x is equal to 0. Okay. All right. So now, in this particular problem, I have an A that's equal to 1, a B that's equal to a negative 8, but what about my C? Do I have a C? No, so that means C would be 0, right? So maybe that type of factoring is not going to be what I need. But when I look at these two terms, what do I notice that they have in common? They both share an x. So I'm going to factor out that x. I'm going to put the x on the outside. So x times what is going to get me x squared? Another x. And x times what is going to get me negative 8x minus 8. And that's going to be equal to 0. And I'm just going to move this up to the top so I have more room. So does zero product property apply here? Absolutely, because I still just have two terms. Here's my A, here's my B. So I can still do the exact same thing. So I have x is equal to 0 or x minus 8 is equal to 0. X is equal to 0 is already solved. Not x is equal to x, even though yes it is. And then when I add 8 over here, then I have x is equal to 8. So this one looks a little bit different, but it's still the same concept of using zero product property, because now my first term is just an x by itself instead of like x plus or minus something. Any questions? Any questions over here? Okay, on to the next one. Next is your quadratic formula. So you want to go ahead and write that down again. I know we've written it down already before, but your quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac. Now, something that is not on here that I'm going to add is this should say when when ax squared plus bx plus c is equal to 0, then x is equal to this. So it has to be in standard form, ax squared plus bx plus c. Do y'all remember quadratic formula from last year? Did you do it in Algebra 1? Maybe. It was a strange year, huh? You don't remember, huh? Very vague. I get it. Okay, we got this written down? Okay, so before we do an example with this problem, let's talk about quadratic formula. So if I come across a problem where I cannot factor, then I'm going to use the quadratic formula, right? So quadratic formula is when I cannot factor, so it's not a number that's factorable. Even though it's written like this is really two numbers. We know it's two numbers because it has this plus or minus right here. So that means I'm going to do two separate problems, negative b plus all the other stuff, and then negative b minus all the other stuff. So this is really two problems that's going to get us two answers, okay? And sometimes the answers will be real numbers. Sometimes the answers will be the same. Sometimes the answers will be imaginary numbers, okay? All right, so how will we know what type of answer we will get? How will we know what type of answer we will get? Well, that information will come from our discriminant. And our discriminant is going to be this number. Yeah, I'm trying to write over here and trying to figure out why it's not working over there. Okay, our discriminant is going to be this number here, b squared minus 4ac. So that is our discriminant. okay? And so the discriminant can tell you how many solutions you're gonna have. The discriminant can tell you how many solutions you're gonna have. So I'm gonna take this off and I'm gonna take you to the table to see about the discriminant. Okay, and let me make this a little bit bigger. Okay, so if your b squared minus 4ac is greater than 0, you're going to have two real solutions, which means it's going to look like a quadratic that we're used to seeing. It's going to cross over the x-axis twice. If your b squared minus 4ac is equal to 0, there's going to be one solution, which means it is only going to touch the x-axis. Notice how it only touches the x-axis at one point. So then you'll end up something like with x minus 2 times x minus 2 equals to 0. If it does not touch the x-axis at all, meaning that your b squared minus 4ac is less than 0, then you're going to have two imaginary solutions. And we're not quite to imaginary numbers yet, but we will get to them real soon. Okay, so take a moment to write this table down so that you can etch this information into your memory, and then we will practice. So my discriminant I got is 16. That means we're going to have two real solutions. Now we want to use quadratic formula. So quadratic formula says x equals -2 plus or minus the square root of our discriminant, which is 16, all over 2 times a, which is 1. So that's going to be -2 plus or minus, what's the square root of 16? 4, all over 2 times 1, which is 2. So remember, this is now two equations. Your first one is going to be -2 plus 4 over 2. And your second one is -2 minus 4 over 2. And 4 minus 2 is 2. 2 over 2 is 1. -2 minus 4 is -6 over 2, which is -3. So x is equal to 1 and x is equal to -3. So I'm going to pause it, let you get it all, and then the final one you're going to do on your own. All right, let's go over this. Okay. Excuse me. Okay, first things first, it needs to be equal to 0. So we're going to add 4 to both sides. So we're going to end up with 5x squared, not 5 squared, 5x squared plus 9x plus 4 equals 0. Okay, so a is equal to 5, b is equal to 9, c is equal to 4. So we're going to find first the discriminant. So that's b squared minus 4ac. So that's going to be 9 squared minus 4 times 5 times 4. All right. Okay. So 9 squared is 81. Oops, not on my equal sign. Negative 4 times 5 is negative 20 times 4. So that's going to be 81 minus 80, which is equal to 1. So if our discriminant is greater than 0, that means we're going to have 2 real solutions. Okay. Then we want to use quadratic formula. So that's going to be x is equal to negative b, which is negative 9, plus or minus the square root of b squared minus 4ac, which is your discriminant, which is just 1, all over 2 times a, which is 5. So then we have negative 9 plus or minus the square root of 1 is just 1 over 2 times 5 is 10. So we take that and we break it up into 2 equations. Our first equation is negative 9 plus 1 over 10. And our second equation is negative 9 minus 1 over 10. So negative 9 plus 1 is negative 8 over 10, which we can reduce to negative 4 over 5. So x is equal to negative 4 over 5. And then our second one, negative 9 minus 1 is negative 10 over 10, which reduces to negative 1. So, and x is equal to negative 1. That was bad. So here's my solution. X is equal to negative 4 over 5, and x is equal to negative 1. Any questions?